Alright, this is on section 6.5, graphing polar coordinates. The first thing that we're going to talk about is the symmetry of your graph. And you can test this algebraically, and there are 3 different tests that you can do. You can test it about the x-axis, which is also known as your polar axis. You can test it about the y-axis, and you can test it against the origin or the pole. To test it, you are going to replace r theta with one of the 2 in this third column here. Okay, so we're going to try an example here to see what happens as we try to prove that it is symmetric. In this first example, it says use the symmetry test to prove that the graph of r equals 4 sine of theta is symmetric about the y-axis. Okay, so what we're going to do is we're going to replace r theta with, and if we go to the y-axis, we want to replace it with negative r, negative theta. Okay, so we're going to plug this in here. So negative r equals 4 sine of 3 times negative theta. Well, 3 times negative theta is negative 3 theta. And what we can use here is our even-odd identities from last unit. And if we remember, the sine of negative theta is equivalent to negative sine of theta. So we're going to use that here and identify that negative r equals negative 4 sine of 3 theta. Now if we divide both sides of this equation by negative 1, that means r is going to equal 4 sine of 3 theta, which is what we began with here. So therefore these are symmetric about the y-axis. In this next example, it kind of proves why we need to have 2 tests for symmetry. Okay? If we look at example 2 here, it says use the symmetry test to prove that the graph r equals 3 plus 3 sine theta is symmetric about the y-axis. So if we do exactly what we did above here and replace r theta with negative r, negative theta, we are looking at negative r equals 3 plus 3 sine of negative theta. Using the same identity that we used above, we get negative r equals 3 minus 3 sine theta. Solving for r by dividing everything by negative 1, r is going to be negative 3 plus 3 sine theta, which is not going to tell us anything because of this negative here. Okay, so this here tells us nothing. So what we need to do is we need to try our other replacement here. So what you're going to do is try replacing r theta with r pi minus theta. So when you plug it in, it's going to look like this. R equals 3 plus 3 sine of pi minus theta. You're going to need to use your sum and difference identity of sine and simplify this here. Alright, our next topic is the rose curve. Alright, with the rose curve, you're going to be actually looking at the graph of these functions, and the general equation is r equals a cosine of n theta, or r equals a sine of n theta. Keep in mind that n is an integer, so it's a whole number or its opposite, and it has to be greater than 1. Okay, so n cannot just be 1. So you have 2 options here, when it's sine and when it's cosine. And the second thing you need to look at is what your n value is. Whether it's even or odd is going to tell you about the graph and what it's symmetric about. Also, the n value will tell you the number of petals. If your n is even, the number of petals is going to be 2 times n. If n is odd, the number of petals is n. Alright, the general characteristics of a rose curve. For all rose curves, the domain is going to be all real numbers, and you can just write all reals. For the range, you have included negative absolute value of a to absolute value of a, and that's included as well. They will always be continuous, and then your symmetry, you have to look and go back to your n value. If n is even, whether it's sine or cosine, it's symmetric about the x, y, and origin. If n is odd, and you have the cosine, it's symmetric about the x-axis. If n is, this should say odd, and you have sine, it's symmetric about the y-axis. Okay? Alright, it is bounded, and the maximum r value is going to be the greatest distance from the pole, which is going to be your a value. Okay. Make sure you take a second and copy all of these down. Shoot, my apologies. Okay, let's look at an example where you are asked to analyze a graph of a rose curve. Okay, in this graph you have r equals 2 sine of 3 theta. If we were to graph this in our calculator, see if you can see this, just going and we graph it, you're going to get this 3-petaled flower-ish thing. Okay? The domain here is going to be all reals. Your range is going to be between -2 and 2, because our a value is 2. It is continuous. And our symmetry, you can either look at the graph or remember that because we have the sine value and our n is odd, that is going to be symmetric about the y-axis. It is bounded, both above and below. Oops, sorry. And our maximum r value is 2. Okay, so that's how you analyze a rose curve. The next one is called a Limacon curve. This is when we have r equals a plus or minus b cosine theta, or r equals a plus or minus b sine theta. Keep in mind that a and b have to be greater than 0 in both cases. Okay? Alright, the domain for these have to be all real numbers. Our range is going to be a minus b and a plus b. They are both continuous. And the symmetry, when you have cosine, it's x-axis. When you have sine, it's going to be over the y-axis. It is bounded, and then the maximum r value, this is our greatest distance from the pole, is going to be a plus b. Alright, there are 4 different types of Limacon curves. I'm going to show you the first one on here, and you're going to try the next 3. You can either do this on your graphing calculator or on Desmos.com. Alright, let's focus on the first one. This is called a Limacon with an inner loop. Okay? Your a over your b values have to be less than 1, and a is less than 1. So let's assume that a is 2 and b is 3. And it doesn't matter if we pick cosine or sine. I'm going to pick the cosine. So if I have r equals 2 plus 3 cosine theta, and we go ahead and let's look at the graph of this. 2 plus 3 cosine theta. And if I hit graph, I get this nice circle, and it has a little baby inner loop here in the middle. So if you could just go ahead and sketch that here on your graph. And looks something like that. It's a little prettier on the calculator, but that's okay. Alright, so what you are going to do tonight is you are going to explore what the cardioid looks like. So you need to pick values of A and B so that they're equal. You need to find out what the dimpled limacon looks like. So your A divided by B has to be between 1 and 2. And then you're going to see what the convex limacon looks like, where your A over B is greater than or equal to 2.